All right, welcome to the practice test video for Chapter 7, Part 2, which covers a lot of trig identities. So I made a helpful and handy list of formulas that you guys will get the exact same sheet for your test. Hopefully this is not too overwhelming and we're familiar with most of these, so we're able to use this pretty efficiently. So here we have our quotient identity, reciprocal, Pythagorean theorem, and even odd formulas, our sum and difference formulas for sine and cosine, our double angle formulas, and our half angle formulas that we covered today. So the first part of this practice test covers establishing identities. So these are the proofs that we did. We're making the left side look exactly like the right side. So let's just jump right into it. Let's make this a little bigger, and we'll go one problem at a time. So step one, if we look at the even odd identities, we see that cotangent is odd. So cotangent of negative angle is the same as the cotangent, negative cotangent squared, which means that's 1 plus cotangent squared theta. 1 plus cotangent squared is cosecant squared. So we're done. Next up, cotangent is 1 over tangent. If I multiply these two, that becomes 1 minus cosine squared theta. Now we know that sine squared plus cosine squared equals 1, so 1 minus cosine squared has to be sine squared theta. So we're done. Number 3. I want to get this in terms of tangents. So I look at what's common to both of these terms, and I can factor out a secant squared. So that's what I'm going to do. Factor out a secant squared, and for this I'm just not going to write the theta till the end. I'm left with secant squared minus 1. Well, now we go and look at our identity list. We see that secant squared is the same as tangent squared plus 1. And we also can see that secant squared minus 1 is the same thing as tangent squared. Now if I distribute this tangent squared back out, I get tangent to the 4th theta plus tan squared, which is exactly what we want. Next up, 1 minus this whole thing. Well, first off, I know that sine squared, we can use exactly what we had up here, is 1 minus cosine squared. This is 1 minus cosine. I can now factor the top because it's the difference of two perfect squares. So that's 1 plus cosine, 1 minus cosine, all over 1 minus cosine. These cancel, so I'm left with 1 minus 1 minus cosine. 1 minus 1 is 0, so I'm just left with negative cosine theta, which is what I want. Moving on to number 5. What we need is a common denominator, so I'm going to multiply this one by cosine. I'm going to multiply this one by 1 plus sine to the top and bottom. Now I'm going to leave the denominator unfoiled, so that's cosine 1 plus sine theta. So on top I have cosine squared plus, foil this out, I get 1 plus 2 sine theta plus sine squared. Now I see that I have cosine squared and sine squared, which is 1. So I have 1 plus 2 sine all over cos, 1 plus sine. 1 plus 1 is 2, so that's 2 plus 2 sine. Factor out a 2 on the top, 1 plus sine, cos 1 plus sine. These cancel, so I'm left with 2 over cosine, which is 2 secant theta, which is what I want. Next up, so what I'm going to do here is I want a tangent times secant on the top. So I'm going to be a little tricky here and notice that I want a common denominator. So secant is 1 over cosine plus tangent is sine over cosine. Cotangent, likewise, is cosine over sine plus cosine over 1. So what I can do with the top here is I can add these two. So I have 1 plus sine over cosine. And on the bottom here, I can get a common denominator. So that has a sine, that has a sine. This is all over cosine times 1 plus sine over sine. Now, hopefully you can see where this is going. Now I have two fractions. So when I divide two fractions together, I flip the guy and multiply. So I have 1 plus sine over cosine times sine over cosine 1 plus sine. And what I got here is those to cancel out. So now I have 1 over cosine times sine over cosine, which gives me, if I just reorder this, tangent theta, secant theta, which is what I wanted. Now that one's a little trickier. We had to get a common denominator there. So moving on to number 7, we're going to have a similar setup as number 6. We're going to split this up. So we're going to get sine squared minus, first thing we're going to rewrite is the tangent. So sine over cosine over, we're going to keep the cosine squared, and then cotangent is cosine over sine. So we're going to get a common denominator here. So I have sine squared, I need a cosine, over cos, minus sine over cosine, divided by, get another common denominator, so that's cosine squared times sine over sine, minus cosine over sine. So let's get that on the camera. Let's give ourselves a little bit more room. Okay, so I have sine squared cosine minus sine over cosine, divided by cosine squared sine minus cosine all over sine. So what's common on the top? I can factor out a sine. So if I factor out a sine, I'm left with sine cos minus 1 all over cosine, divided by, same thing on the bottom, there's a cosine in common, so it's cosine times sine cos minus 1 all over sine. Now what this allows me to do is now I have two fractions divided by each other, so I can flip the guy and multiply. So this gives me sine cos minus 1 over cosine times the reciprocal. So sine over cosine sine cosine minus 1. Now if we notice, these two quantities cancel out. I have sine times sine over cosine times cosine. So that's sine squared over cosine squared. And sine squared over cosine squared gives me tangent squared theta, which is exactly what I want. Next up, number 8. I notice this is a sum or difference problem, so I'm going to separate this out. So sine A plus B, sine is slow, so it's sine A cos B plus, because sine stay the same, cos A sine B, all over cos A cos B. So second step, split the fractions up. So I have sine A cosine B over cosine A cosine B plus cosine A sine B all over cos A cos B. So now we should recognize that the cosine B's cancel, so I have sine A over cosine A, which gives me the tangent of A, plus cosines cancel, sine B over cosine B is tangent B, which is what I want, and I'm done. So that takes care of all of the identities, and now we can move on to double angle, half angle, and sum and product rule. So on the second page, we see that, starting with number 8, we're given the sine of an angle, we're given a trig ratio, so sine theta equals 6 over 10, and pi over 2, theta is between pi over 2 and pi. So whenever you're given something like this, you need to draw a picture of a right triangle. This gives us the second quadrant. Sine is 6 over 10, so this is 6 blank 10 right triangle, so that side's negative 8. You can always do the Pythagorean theorem to double check. So sine of 2 theta. Well, from our double angle formula, we know that it's 2 sine theta cosine theta. So sine, we're given with 6 over 10. Cosine is negative 8 over 10. So all we do is plug in. 2 times 6 over 10, because that's what sine is, times negative 8 over 10. So 6 times 8 is 48, times 2 is 96 over 100, negative 96 over 100. Or if we simplify this, this is negative 24 out of 25. Now sticking with this, finding the cosine of pi over 2, we use our formula. We look at the half angle formula, and the formula is, since this is in the second quadrant, cosine's negative, so that's the square root, negative square root of 1 plus negative 8 tenths all over 2. It's a whole square root. So now it's just simplifying. I have negative 2 tenths. Sorry, 1 minus 8 tenths is 2 tenths, or 1/5. Half of 1/5 is 1/10. So this is the square root of 1/10, which is the square root of 1 over the square root of 10, which is the square root of 10 all over 10. And it's negative because cosine's negative in the second quadrant. Moving on. Use the half angle formulas to find the exact value. So we need to know what theta over 2 is. So what's half? Negative pi over 6 is half of negative pi over 3 all over 2. So sine, if we have a negative angle, is going to be negative. So this is going to be the negative square root of 1 minus cosine of theta over 2. So cosine of theta is negative pi over 3. So cosine of negative pi over 3 is 1/2. So I have negative square root of 1 minus 1/2 all over 2. 1 minus a half is a half. Divided by 2 is a fourth. So this is the negative square root of 1 over 4, which is negative 1/2. Which makes sense, because what is the sine of negative pi over 6? Negative 1/2. So our algebra works out. So the cosine of 22.5. What half of what angle is 22 and a half? That's 45 over 2. So we look at our formula. This is in the first quadrant, so this is positive. 1 plus cosine of theta over 2. That's our theta. So that's the 1 plus square root of 2 over 2 divided by 2. So this is 2 square root of, this is 2 over 2, 2 plus the square root of 2 all over 4. That's the most exact we're going to leave our answer. And you can leave it just like that. Next up, if it's known that sine alpha is 5/3, let's zoom out just a little bit so we can get this all on the screen. Whenever we're given this, draw a picture. So alpha is in the first quadrant. There's our alpha. 5, 13. If we don't remember this, 5 blank 13 triangle, that side's 12. You can always do the Pythagorean theorem to double check this. So what's our sine of alpha? That is 5 over 13. We're given that. What's the cosine of alpha? 12 over 13. Next up, between pi and 3 pi over 2. Our beta angle is in the fourth quadrant. Sorry. Oh, be careful, Mr. Swenson. This is in the third quadrant between pi and 3 pi over 2. So there's beta. So sine of beta is negative 3/5. That's negative 4. So then we can find out what beta is. So sine beta is negative 3/5. Cosine beta is negative 4/5. So now we can do these two problems. Cosine, sum or difference is quick. It's cosine, sine. So I'm going to write that out. It's cosine alpha, cosine beta. Cosine signs change, so plus sine alpha, sine beta. Now we just plug in the values. Cosine alpha is 12 over 13. Cosine beta is negative 4/5. Plus sine alpha is 5/13. Sine beta is negative 3/5. So 12 times negative 4 is negative 48 over 65 plus negative 15 over 65. So that becomes negative 63 over 65. Next up, for sine, sine is slower, so sine alpha, cosine beta, sine stay the same, plus cosine alpha, sine beta. Now we just plug in again. Sine alpha, 5/13, cosine beta, negative 4/5, plus cosine alpha, 12/13, sine beta, negative 3/5. 5 times negative 4, negative 20 over 65, plus 12 times negative 3, which is negative 36 over 65. Negative 20 plus negative 36 is negative 56 over 65. Last couple. Here's again using the sum or difference formula. So we look at our formula. We see that this is sine, cosine. So that's got to be sine. So that's 30 and 60. We look at our sines. Sine stay the same, so that's plus. So this is asking you, what is the sine of 90 degrees? And the sine of 90 degrees, remember our unit circle, that's going to be 1. So next up, sine. So that's got to be cosine. Cosine of what? Cosine of 130 and 10. Cosine changes, so that sign becomes a minus. So that's the cosine of 120. So we go, what's the cosine of 120? negative 1/2. Same thing as 2 pi over 3. Last problems. Again, let's keep that on the screen. So we want, first, we're given this. Do we need to draw a picture? No, because we're just using the half angle formula. So what do? Sine is subtraction. 1 minus, what's the cosine of alpha? 5/12 over 2. So 12 minus 5 is 7. 7/12 divided by 2 is the square root of 7/24. We shouldn't leave our answer like this. Is there a perfect square in here? Yes. This is the square root of 7 over 2 root 6. So if I rationalize that, I get the square root of 42 over 12. So that is the most exact answer. I'll probably take this on Friday, but you guys should be able to rationalize this. So I go with cosine. Cosine is 1 plus 5/12 over 2. 12 plus 5 is 17. So this is the square root of 17 over 24. So again, this is the square root of 17 over 2 root 6. Rationalize this. 6 times 17 is 60 plus 42, so that's 102. So that's the square root of 102 over 12. Double check my math on that. That was quick. That was 6 times 10, 6 times 7, add those two together. So that sounds right. Hopefully this video helps you out. Remember, you'll have a partner to work with, and you'll have this formula sheet. So good luck studying.